We're covering wireless LAN architectures for the CCNA exam, specifically autonomous versus lightweight access points. The exam will test your ability to distinguish between these two core architectures and know when to deploy each one. An autonomous AP is a standalone device, sometimes called a FAT AP, that has all the intelligence and configuration stored locally. You configure each one individually, which is manageable for a small office with 1 or 2 APs, but becomes operationally impossible as you scale to dozens or hundreds. For the exam, think of autonomous APs as legacy or for very small, simple deployments. The modern enterprise solution, and the focus of the CCNA, is the lightweight AP architecture. These are thin APs that are controlled by a central wireless LAN controller, or WLC. This model uses a concept called split MAC architecture. The exam loves to ask about this. It means that the functions of an access point are split. The lightweight AP handles the real-time, time-sensitive functions like sending beacons and acknowledgements, while the WLC handles the management functions like authentication, security policies, and roaming. Communication between the lightweight AP and the WLC happens over a CAPWAP tunnel. Remember that CAPWAP stands for Control and Provisioning of Wireless Access Points. A huge exam trap is confusing the two tunnels within CAPWAP. The CAPWAP control tunnel, which runs on UDP port 5246, carries management traffic and is always encrypted with DTLS. The CAPWAP data tunnel on UDP port 5247 carries the actual client traffic and is not encrypted by default. You must know this distinction. Now, let's talk about deployment models. In a centralized or local mode deployment, all traffic from wireless clients is sent through the CAPWAP data tunnel to the WLC. The WLC then puts the data onto the wired network. This is simple, but if you have an AP in a remote branch office and the WLC is at headquarters, all of that branch's traffic has to travel across the WAN to the WLC and then potentially back to the branch, which is very inefficient. The solution is FlexConnect, a mode designed for branch offices. In FlexConnect mode, the AP is still managed by the central WLC, but it can switch client data traffic locally onto the branch office network. This saves WAN bandwidth. A common exam scenario involves a WAN link failure. With FlexConnect, if the AP loses connectivity to the WLC, it can enter standalone mode and continue to serve existing and even new clients on that local network, providing survivability. A centralized AP would stop functioning entirely. For a mental shortcut, remember this. The WLC is the brains, the AT is the brawn. The WLC handles the complex thinking and management, while the AT does the heavy lifting of moving radio frames. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.